Question 2, Part D. Sketch the graph of the function f of x equals 2 times inverse cos of x. Clearly indicate the domain and range of the function. Start by dividing both sides of the equation by 2 to isolate inverse cos of x. So the equation becomes f of x over 2 is equal to inverse cos of x. Now let's consider the domain of the function. The function inverse cos expects a value of x in between -1 and 1 inclusive of the endpoints. So the domain is unchanged when compared to the base curve y equals inverse cos of x. So the domain is x is greater than or equal to -1 and less than or equal to 1. Now the range of inverse cos of x is between 0 and pi inclusive. Now the range, or the y values in this case, is represented by f of x over 2. So f of x over 2 is a value between 0 and pi inclusive. But we need to isolate f of x. We do that by multiplying all three terms of this three-way inequality by the denominator 2. So multiplying 0 by 2, we get 0. Multiplying pi by 2, we get 2 pi. Hence, f of x is greater than or equal to 0 and less than or equal to 2 pi, which is the range of f of x equals 2 times inverse cos of x. So what's happened is that the base curve y equals inverse cos of x has been dilated or stretched vertically by a factor of 2. And that's shown in this graph. We can see that the shape of the graph resembles the base curve y equals inverse cos of x. The domain is identical to the base curve, that is from x equals -1 to x equals 1, but the range is double. So rather than the range being from 0 to pi, it's now from 0 to 2 pi. And I've indicated that on the endpoints of this graph. Also note the y-intercept is pi rather than pi over 2.